Howdy, good morning. So many of you have your own televisions, but probably not many of you have a 60-inch television in your bedroom. However, what do they mean when they say your television is 60 inches? What is a 60-inch television? For that matter, what is a 52-inch television? What is a 30-inch television? What is that a measurement of? I want you to ponder that for a second. We'll discover the answer here in a second, but I want you to think about that. Where do you think that measurement comes from? That's a good, intelligent question that needs to be answered, and it's what we're going to answer here in this lesson today. So, let's talk about good things. Good things. Y'all know I'm a beekeeper. You know the story about my kids getting their bees stolen right off our property, and how some good Samaritan beekeeper decided to bless us with 2 beehives. And then last week on Thursday, we inspected the hives, and the hives were really, really mean, and they were attacking us, and we had to leave our property, and we didn't know what we were going to do. We were actually in the process of Saturday, we were going to go ahead and we were going to requeen them. But when we opened up the hive, we discovered that the hive became very docile, and the bees were not upset at all. And the queen is working really hard, which means that the beehive is very, very healthy. There's no signs of disease. There's no reason for us to get rid of that queen. As a matter of fact, today I'm going to pick up a honey extractor, and we're going to harvest some honey, and we'll be able to sell some of that honey real soon. Anyway, that's our good things. Still waiting on some of you to share with me some of the good things that you have. Please tell me in class or otherwise. Send me an email or a message in Google Classroom telling me what's good going on in your life. I'd like to share with your fellow students. And I promise I'll keep it anonymous unless you want me to. So let's move on. All right. How are today's television different from older models? And when you watch some movies on the television, why are there black bars at the top and bottom of the screen when you're watching on an old TV? And for that matter, when you're watching an old movie on a newer TV, why are there black bars at the left and right side of the screen? So we'll look into that in a little more detail. I want you to think about that for a second. How are today's televisions different from older models? Are they different sizes? Are they bigger? Well, I'm pretty sure that we can all agree that they're bigger. But what about their shapes? Are their shapes different? If they're shaped different and the movies were made to fit those screens, that might explain why those black bars exist. So, for a rectangular shape, such as a display screen, the longer side is always called the width, and the shorter side is always called the height. And the aspect ratio is always in this configuration, width to height, either width colon height or width over height. So the AR, or the aspect ratio, is always some fraction, the width over the height, or width divided by height. So that is the aspect ratio, the ratio of the width to the height. So in other words, if you can discover what that decimal number is, we can turn it into a percentage and say that the width is a certain percentage of the height. Does that make sense? Anyway. What is the approximate aspect ratio of the screen on your graphing calculator or your cell phone? Consider only the window, not the entire screen. So if you look at your calculator or even your window on your cell phone, you'll see that it kind of looks like, I don't know, a little bit wider than it is high. And have you ever heard a graphing calculator display called a friendly window? I mean, looking at the screen you're looking at right now on your phone or on your computer, it's wider than it is high, and it's called a friendly window for a reason. What do you think that aspect ratio is? Obviously, the width is longer than the height, so if it's width over height, that aspect ratio is going to be greater than 1. If you divide the height into the width, the resulting quotient will be greater than 1. So the size of a television is the length of the diagonal of its screen in inches. So the aspect ratio of screens of older televisions is 4:3. So if you look at the area on a 55-inch TV that is a 4:3 ratio, you have a video area of 1,449 square inches. Well, the aspect ratio of newer widescreen televisions is 16:9, and a 55-inch television that has a 16:9 ratio only has a video area of 1,291 square inches. Now, well, that's not a really good trade-off. You think there's not enough viewing area. Well, actually, that screen, that 16:9 screen, is a friendlier viewing area. If you think about the width of your eyes, how they are apart, you have to focus more concentrated on the 4:3 than you do on the 16:9. Your eyes don't have to focus as much because your eyes are further apart than they are high. So that kind of makes a distinction for you. So find the width and height of an older 25-inch television whose screen has an aspect ratio of 4:3. And find the area of the viewing screen. Well, if it's 25 inches, what we need to look at is what do we know about the whole television. We know that the width to the height is 4:3. So we can actually say that if we put a little triangle in there, 4:3, you see the 4:3, and then the 25 is this is 4:3, this is the little triangle in here. We don't know what the height and we don't know what the width is to the 25-inch TV. And we'll recall geometric relationships of similar right triangles. If two objects are similar, corresponding angles are congruent, and their sides are proportional in length. So height is proportional to 3, like width is proportional to 4, like 25 is proportional to C. And we'll use the Pythagorean theorem to discover what C is. 3 squared plus 4 squared equals C squared. And of course, 3 squared is 9 plus 4 squared is 16. 16 plus 9 is 25. The square root of 25 is 5. So 25 divided by 5 equals h over 3. So we can do the cross multiplication here and discover what h is. The height is going to be 15 inches. And do the same thing with the width. Look at the ratio of 25 to 5 because they are similar to these two lengths, width and the 4. So 25 over 5 equals the width over 4. And we'll do cross multiplication. It'll be 25 times 4 resulting in 100 and 5 times w resulting in 5w. And we'll divide both sides by 5 to isolate the w on one side to discover what the answer to w is. 5 and 100 is 20, and the answer to the width is 20 inches. So, do you recognize the 3, 4, 5 triangle? I've discussed it in class. That is what the Greeks used to make square on their blocks when they were building the pyramids. They would have a 12-inch rope, and they would knot it or notch it or tape it or put some kind of twine on it at 3 foot, 4 foot, and then you'd have 5 foot left. And if you put it where 5 foot was there and you had the corner of one, you would actually have exactly a square on that corner. Interesting. The area of the viewing screen, 15 by 20, is 300 inches square. What about a 16:9 that has a 48-inch television? Now, I put 25-inch here. That's a mistake. I apologize. I'm going to go in there and fix that right now. How's that? For on the fly, working. There we go. Present, and we're back into the screen. What is the height and width of a newer 40-inch television screen? Well, it's the same thing here, but it's a little different. You've got the 9 and 16. The width is 16. The height is 9. 48 to C, we don't know what C is. We have to do the Pythagorean theorem. And we're going to say if two objects are similar, corresponding angles and they are congruent, and their sides are proportional in length. So this hypotenuse is proportional to this hypotenuse. This width is proportional to this width, 16. This height is proportional to this height, 9. So we can use Pythagorean theorem, 9 squared plus 16 squared. 9 squared is 81, 16 squared is 256. You add it together, you get 337. The square root of 337 is 18.357. So we'll divide 48 by that because that is the ratio. Hypotenuse over hypotenuse is height over height, or height over 9 in this case. So we'll divide 432, which is 48 times 9, by 18.357, we'll find that the height is 23.533 inches. And we'll do the same thing here with the width and discover that the width is 41.837 inches. Notice that the height is always smaller than the width. We said in those kind of situations, the width is always bigger than the height. All right, and the area of the viewing screen we'll apply together, 984.529 square inches. When movies that were made in one aspect ratio are shown on televisions that have a different aspect ratio, black bars of equal width cover a portion of the screen. Portions of the screen are not needed to project images that were created with different aspect ratios. When we display a 4:3 image on a 16:9 screen, we'll get pillar box bars. You'll get a pillar box image. It's just, you'll have these two pillar black bars. And when you display a 16:9 image on a 4:3 screen, you'll get these black bars on the top and bottom, and it's called a letterbox image. Does that make sense? This is your 4:3 image on a widescreen TV. This is a widescreen image on a 4:3 old black and white or whatever kind of TV it was. All right. Figure 1 shows a letterboxed image with an aspect ratio of 16:9 displayed on the screen with an aspect ratio of 4:3. What percentage of the screen's area is occupied by the image? And we have to justify our answer. Now let's think about this for a second. If we look at it from the perspective of how much is left, okay, we have a 16:9 image. If we know that it's 16:9 and this is 4:3, we'll go, this is 3 to 9 and this is 4 to 16, right? So what is our percentage left? Think about that. 9 to 3 is 3. 16 by 4 is 4. So we got 3/4 left. 3/4 of the screen is filled with what? The image. That means what's left? 1/4 of the image is left that does not, or 1/4 of the screen is left without an image. Therefore, we can say that 3/4 or 75% of the screen's area is occupied by the image. Now, what would happen if the image, if it filled the height of the entire screen? Well, that really depends on how you want to fill it up. Let's say that we just pulled the image up and pulled the image down. You're familiar with doing that if you manipulate pictures inside when you're doing a slideshow, which we should have done a little bit of when we were doing our Fermi project. In that presentation, if you slide any of those images up, what happens to the image? It stretches. So it distorts the image by making it taller than it actually is when you took the picture. Figure 2 shows a pillar boxed image with an aspect ratio of 4:3 displayed on a screen with an aspect ratio of 16:9. Now, what percentage of the screen is occupied by the image, and justify your answer? Okay, we're going to have a 4:3 image on a 16. So this is 4 to 3, and this is 16 to 9. Well, we're looking at the same thing, 4 over 16 and 3 over 9. Well, 4 over 16 is what? It's 4, right? Or 1/4. And 3 over 9 is 1/3. Now, how do we determine exactly what we're looking at here? What percentage of the screen is occupied by the image? Okay, well, look at it from this perspective. What are we looking at here? We have 16, and this is 4, right? 16 and 4. 4 times 4 is 16. Okay? Now, this is 3, and this is 9. 3 times 4 is 12, right? Okay, so now we're looking at 12/9. Okay, if this is 9 and we're to make this the same aspect ratio, this is 12 and this is 9. We're looking at 1/4 more that's missing. So we're missing 1/4 of the image here and here. Now, if you think about that for a second, that makes a lot of sense. 75% of the screen is the image, and the other 25% is the black bars. Just like the last one, we're looking at a situation where only 75% of the image is actually there. All right, people who own a widescreen television can choose one of three views of a 4:3 image on the display. The normal view, which is shown in the picture, shows the pillar box. Another option is to stretch the width of the image, keeping the height the same. What does that do to the image? We'll talk about that here in a second. Third option is to zoom in on the image, making the width of the image take the full width of the display. Now, what effect do we have on these images? Okay, the one with the pillar box is obvious. It shows it's got those black bars on the right and left. But what if we stretch the width of the image? Doesn't that distort the image? It makes the bird wider than it actually is. Yeah, that kind of is what happens. The third option is to zoom in on the image to make the image actually fill the width of the display. What happens to the top and bottom of that image? It gets cut off because it also gets zoomed out, and it gets zoomed out of the picture frame. Okay? So this is a bell ringer. What is the largest size television with an aspect ratio 16:9 to fill a 46 by 36 inch space? I'm going to let you look at that for a second, and I want you to think about it. We'll talk about that here in a minute. All right. When changing the size of a rectangular image using a computer drawing program, how can you maintain the same aspect ratio? This image kind of shows you how we do it. Just think about that for a minute. You'll figure it out. All right. Using appropriate measuring device, determine the aspect ratio of several objects. First class piece of mail, letter or postcard must have an aspect ratio falls between 1.3 and 25 inclusive. Wow, 1.3. That means that the width can only be 130% of the length. Does that make sense? So 8.5 by 11 falls into it because it's exactly 130%. The length is actually, well, it should be width and length, but you see how that works. We call it the length. It's actually the height. The width is 8.5. No, that's not how it works. Length is 8.5. Width is 8. Or height is 8. You get it. Width over height. Width is supposed to be longer than the height. In this situation, we're looking at just a piece of paper. Index card. You can think of other things. How about the projector screen, or maybe the whiteboard? What is the aspect ratio of the whiteboard? Do a little measurement, you could actually determine what that aspect ratio is. Generally speaking, if you're talking about an aspect ratio, it's almost always considered the percentage that one length or one measurement is over another measurement on that device. All right, some figures have what is known as the golden ratio, which is an aspect ratio that is considered to be visually appealing. Rectangles that have a golden aspect ratio are often called golden rectangles. Which of the following rectangles is a golden rectangle? Is it this one, this one, this one, or this one? I think you can answer that quickly. If you look at the one that looks most like your flat screen television, it's not that one or this one, is it? And it's definitely not that one. It means this can be the only one. Doesn't that look like the front of your screen on your computer, or maybe the television that you look at every day? So, second rectangle from the left is the golden ratio. I'm going to launch you with this. The golden ratio exists in architecture because it is very pleasing to the eye. This is a picture of the U.S. Capitol. And I know you're looking at all these numbers and letters and like, what in the world? The aspect ratio is 1 to 1.618. So in other words, we're looking at a height that has an aspect ratio of 1.6, or a width that has an aspect ratio 1.618 to the height. I won't explain to you what this is. I might do this in class. Every one of these creates what is known as a really pleasing sight to the person. So, all right, have a great day, and be blessed, be a blessing.